Hello, welcome to the calculus class. We're teaching out of the free textbook by Rice University. It's called Openstax Calculus. It's completely free to download, which is why I'm teaching out of it, so that it's easier for the students to find the book without having to pay a boatload of money, right? And so we are starting with volume 1, and so I will go over chapter 1. Even though chapter 1 is mostly review, so it's not strictly speaking calculus, but it's important to do some reviews if you're not that familiar or if it's been a while since you studied algebra. One point I want to make very clear is that calculus is easy if you know algebra. Most people have a hard time with calculus because they are not good at algebra. It's kind of like they're not prepared, like a chef who is trying to cook without ingredients. It doesn't make him a bad chef, it just means he doesn't have ingredients. And similarly, if you are not good at calculus, chances are you didn't study algebra thoroughly. And I don't mean all of algebra, just a small part of it. Just the beginning part where you know all the manipulations, like how to multiply, divide, the least common denominator, rules, and so on and so forth. Basically, the arithmetic part of algebra has to be down packed. Okay, so if you're not that good at it, you can go through online practices or something until you know exactly how to manipulate algebraic equations. It's very, very important. And once you have done that, then calculus is, well, no harder than algebra, really. It's just an extension of it, basically. So having said that, let's start with chapter 1. Come on, where's chapter 1? All right, being that chapter 1 is just a review, I'm not going to go into that much detail. I just quickly go through it so we can get to chapter 2 or somewhere that there's actual calculus going on. So first, what is a function? A function is something, in terms of calculus, is something that has a domain and a range. As an example of a function would be, well, you will know it as soon as I take the lid off this thing there. Okay, so a function, and an example of a function, let's make one up, is say f of x equals to x plus 1. A function has something that's called the domain, which is the values x is allowed to be, and in this case x can be whatever. And the range is what the function can become, and that is what is the value of f of x. And in this simple function it can be whatever, which whatever in math is sometimes called from minus infinity to infinity, which is a fancy way of saying whatever, any number you want. So, and always remember, the infinity symbol is kind of charming in math. People like to talk about it, but it's actually not a number. It's just a direction, okay? Because you cannot reach infinity. There is no end. So, some notations of functions, like for example, let's say if just because the x can be whatever number you want doesn't mean it has to be. You can artificially restrict it. For example, you might want to restrict x to be between 1 and 5 only. So you can write down my domain is such that this is the set of x such that x is between 1 and 5, okay? That's just my personal preference. It's not what x could be. It's just being restricted right now by me. So this bunch of symbols means that this is the set of x such that x is larger than 1 and less than 5. And now notice the bunch of symbols. Don't let the bunch of symbols blow you away. Okay, the symbol is just language. It's like Russian. Okay, I mean Russian is hard until you learn how to speak it. Then it's nothing. It's just what every Russian speaks, right? And this is just the language, and once you know what it says, then that's there's nothing to it. Now, math or calculus is a lot of times considered difficult because the language being used looks cryptic to somebody who doesn't know what it says. But while math can be difficult in essence, do not confuse the difficulty of language with the difficulty of logical deductions. That is, if the difficulty is only in language, basically anybody can learn the language. Okay, it's like Russian or English or Chinese. Once you learn the language, then you can speak it. Okay, yeah. There's nothing to languages, so to speak. So next, let's okay. As an example of the function for the review, let's look at a quick and easy example, example 1.1, which is which just says f of x equals to 3x squared plus 2x and then minus 1. All right. So, and then we're supposed to let's calculate f of minus 2. So the function is an instruction. The reason that a function has parentheses, it means that you have to pretend or imagine that x is now minus 2. And that's your position. Or you can put it this way, is the function is like a machine, okay? This is where the machine's input. Right now, I want you to put minus 2 in the location of x. And what does the machine do? The machine will take whatever you input, minus 2, which is now x, and put it in here and perform this particular operation and come up with some form of answer. So you have 3 times minus 2 squared, that's like 12. Then minus 4, that's 8. Minus 1, that's 7. Now, if I didn't get that wrong, then, yep. And according to the textbook, that's correct. All right. And the other stuff is very similar. Let's look at a more difficult problem, which you will look at, say, the third option, is, okay, f of a plus h. Now, that is not a number, but the principle is exactly the same. So you do, now remember, a plus h is now the new x, okay? Sometimes people say that red is the new black, or some other color is the new black. Well, right now, a plus h together is the new x. So you put this entire object into x blindly, okay, like a machine would do. So you put this whole thing, a plus h squared. The reason I have parentheses is because you have to square the entire x, and x includes a and h. So you square that, plus 2 times a plus h, and then minus 1. And now we have come to what I mentioned earlier about algebra. And you need to know how to do this. And I will not explain it because this is just the basics, right? If you can remember how this is done, better dig out the algebra stuff and work on this again until you remember exactly how it's done. So anyway, so by the time you get done with the algebra, you will come up with some kind of an answer, which is in your book. But it's very, very important when you study math to practice the examples in the book by covering it. You know, once you know how it's done, you cover it or not look at it, and then redo this yourself. See if you can do it. It's like the answer is right here, but it doesn't hurt you to practice. Or it's like exercising, okay? Just because you know how to exercise doesn't mean you shouldn't do it. Exercising will strengthen your muscle, and getting good at math consists of practicing until you know how it's done. Preferably practicing it so much that you can do it in your sleep. And that's algebra, okay? And you need to be that good at algebra to be good or comfortable at calculus. Remember, calculus is considered a tough class in college, but in reality, it all depends on how good you are at practicing algebra. Next, we talk about finding the domain and range. The domain is all the numbers that x can be for this purpose. It can also be artificially designed so that I call the domain 1 to 5. Okay, that's how I like it. That you can do that too. But normally in the math problem, when they ask you for the domain, they merely ask what could x be that would make sense in this. Because sometimes the x wouldn't make any sense at all. For example, let's look at the next example, which is f of x. This is on page 12. F of x equals to 3 over x minus 2. All right, now the domain is such that this thing has to mean something, and the denominator cannot be 0 ever. So x being 0 does not make sense. So the only thing that you have to worry about the domain is that the domain is the set of all x such that x is not 2. But I mean the denominator can't be 0. So because you cannot divide by 0, so which means x cannot be 2, because 2 minus 2 is 0. So the set language says the domain is a set of all x such that x is not equal to 2. All right. And next, we will look at, and then we can also talk about the range. What can the range be? Well, the range can be, range is what is the value of f of x once you enter some kind of x and came up with a calculation. Well, in this case, the range can be whatever. Now, in this case, then the range can be, the range can also be whatever, right? Because any number you want for f of x, you can come up with an x that works by using simple algebraic manipulation. For example, let's make up a number like say minus 100, right? So I want f of x to be minus 100. What should x be? So you do this thing, and to solve this equation, you have to do your algebraic manipulation that I was talking about. Know exactly how to solve this thing in your sleep. Very important. Remember, if you don't, you're not sure. If you look at this and you can't remember how it's done, go back and practice this stuff. Okay? So the way to do it is here's the equal sign. You do so-called cross multiplication. That's one way. And so you have minus 100, okay, divided by 3. And then this goes down. And then this goes, let me erase this, times x minus 2, and then that equals to 1. And then you have to multiply this out. So we have 1 minus 100 over 3 times x plus 200 over 3 equals 1. And then you have to do something like this. Okay, now minus 100x over 3 plus, okay, 1, and then plus, you multiply this by this, 100 times 200, divide by 3. And then you have to do other stuff, which, yeah, I wish I hadn't done that, because that is probably not the most convenient example. But anyway, you continue to do this until you come up with an x for which this relationship exists. That is, the f of x equal to minus 100. The point is that it doesn't matter what you do. I mean, it doesn't matter what value of f of x you can pick. You will always be able to come up with some kind of x by this operation, and which this is not pretty, so I'm going to stop right here. Because I don't like non-pretty math. But the idea is there, is that if you just manipulate, then you can come up with a value of f of x. Therefore, the range of f is all numbers like this, minus infinity to infinity.